guys, today we are going to be going over MCAP practice problems. I've pulled the MCAP practice paper pencil test from, this is February 2024, so I've pulled it from the MCAP website, and we're going to look over it and answer how to solve these problems. I'm going to do it in 4 different sections so that, because that way it's not too overwhelming all at once. So the first section is what I'm going to cover in this video, and it is the non-calculator section. So with this first one, we are going to be looking at equations of a circle. So the equation formula for a circle is x minus h squared, quantity squared, plus y minus k, that quantity squared, equals r squared, in which the center of the circle would then be h comma k, and r stands for the radius. All right, so in this situation, if you put it into the form of x minus h squared, this first section here, if you think of that plus as a minus negative, so that's actually an x minus a negative 4, then our h is actually negative 4. And if you look at that y minus 3, it's already a y minus a number, so it's a positive 3 that's being subtracted. So it's a positive 3 for the k coordinate. And so our center is at negative 4, 3. And then it's equal to 36. Well, remember, for equation of a circle, r squared is what's on that side of the equal sign. So if you think of that 36 as 6 squared, sorry, the pen doesn't work great on here. So think of 36 as 6 squared, then the radius is equal to 6. So center being negative 4, 3. Oh, Nikes, how did I do that? I don't even know how to get it back now. There we go. Okay, back to normal. So our center is at 4, 3. Sorry, I drew some lines on there trying to figure that out. Let me get. So 4, negative 3, we said what, or sorry, negative 4, 3 was our center, so it's either got to be C or D, because these are positive 4 and negative 3. When we figured out that it was negative 4, 3, and our radius is 6, is what we discovered. So out of these two, C is our correct answer, because on this one they said the radius was 36. So that's number 1 for you. Number 2, bear with me, this is the first time I'm using PowerPoint screenshot. Oh, I don't want to do that. This is hilarious. How do I zoom out? There we go. All right. So how, let's see if I can use my computer. Oh my God. I'm going to pause this for a second while I figure something out. All right, I think I figured this out. I'm just going to pause between each question and then play with it that way. So bear with me. All right, number 2. It says, given the parallelogram PQRS, let me see if I have my drawback on. I don't. I just have it on regular computer. All right, I think I figured it out. Okay, so now on number 2, it says parallelogram PQRS with angle P being 90 degrees. So that's a part of our given information. So angle P is 90 degrees. Prove that parallelogram PQRS is a rectangle, so a specific type of parallelogram. So what we know about parallelograms is the opposite sides are parallel. That's just the definition of a parallelogram, okay? So based on that, when they've given you most of the proof, what we need to figure out is what's going here and what's going here for those justifications. So after stating that this is a parallelogram and the angle P is 90 degrees, they want us to tell why we know angle P and angle Q are supplementary. So the reason we know angle P and angle Q are supplementary is that by definition of a parallelogram, think of it like we've got two parallel lines and a transversal. So these would be same side interior angles, so they would add to be 180. So they would be supplementary. So the reason we would give for that is consecutive angles, which means angles next to each other, and a parallelogram are supplementary. Now, I'm not going to write all that there. You'll see it on our options for when we're given choices A, B, C, or D. Moving on, after we've shown that angle Q is 90 degrees, then they make the statement that angle P and angle R are congruent, and angle Q and angle S are congruent. So angle P and angle R being congruent, so that, and angle Q and angle S. So we're talking opposite angles of a parallelogram. And what we know about opposite angles by definition that goes along with the definition of parallelogram is some of its attributes or properties are that opposite angles of a parallelogram are congruent to each other. And so that would be our justification for right here. So let me get my pointer. So out of these options for this problem for number 2, it says, what are the reasons for step 2 and step 6? So the reason for step 2 was that the reason why P and Q are supplementary is because angles that are next to each other in a parallelogram are supplementary. So it's not by definition of a linear pair, because remember, definition of a linear pair means if I have two angles next to each other making a straight line, they add up to be 180. And that was not the case. These were angles that were consecutive angles of a parallelogram, angles next to each other in a parallelogram. So it's not going to be A and it's not going to be B. So out of C and D, the step 2 reasoning was consecutive angles of a parallelogram are supplementary. So angles next to each other add up to be 180. And then for step 6, stating about opposite angles being, if a parallelogram being congruent, that would be D. On this part C where it says for step 6, vertical angles being congruent, that's when you have two intersecting lines and angles opposite each other are equal to each other. And that was not the case with our parallelogram. These were angles that were opposite each other, like that. Okay, so it's not C, so our answer is D. For number 3, we are told that angle K, I don't know why that's there, and angle R are congruent. And it says, which angles have a cosine that is equal to the sine of L? So this is trig. So remember with trig, we've got SOHCAHTOA. So sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse. And tangent of an angle is opposite over adjacent. All right, so it's saying which angles have a cosine that's equal to the sine of L? So here's angle L. Its opposite side is here, and its hypotenuse side is here of that triangle. So remember, opposite from the angle you're referencing, and then hypotenuse is always opposite from the 90-degree angle. So same thing goes over here. Since this is a right angle, that's a right angle, these two angles are equal, then these two angles are equal. So sine of L would also be the same as sine of S, but what we're looking for is what would be equivalent to sine of L, but it's cosine this time. So this time, cosine, we need to find an angle where L's opposite over hypotenuse would be the same as this angle's adjacent over hypotenuse. So this angle here would have to be the adjacent side, and it would be over hypotenuse.
Catherine, your order is here. Catherine, please come to the main office.
So this adjacent side is adjacent to K. So cosine of K would be this side over the hypotenuse. So cosine of K works, so B is one of our answers. And looking at this triangle, same setup. Think of this as the one that's similar to K. So this would be the adjacent and the hypotenuse that would be equivalent to that. So angle R as well. Cosine of angle R would also be equivalent to that. And R in this example, let me find it. This is number 3. Sorry, I'm looking at my paper copy because this little box on my screen that says turn on and draw is in my way, and it's driving me crazy. So on the paper practice test, E is underneath this box right here, which says that, here I'll write it out to the side, E is talking about angle R. Cosine of a, so ignore all this. Cosine of R is answer E. So the answer for that one is B and E. Sorry this is so sloppy and it's being a pain in the butt, but this is what I'm working with right now. All right, for number 4, it says, in the XY plane, our triangle RST is the first reflected across the x-axis and then reflected across the y-axis and finally rotated about 180 degrees about the origin to obtain the image of R prime, S prime, T prime. So I'm a visual person. So if you think of this as your X and this is your Y, if I have triangle RST down here, if I reflect it across the x-axis, it would look something like that. And then if I then reflect it across the y-axis, it would look something like that. And then to rotate it 180 degrees would actually take us right back to our original position. So it says, which statements correctly describe the relationship between triangle RST and triangle R prime, S prime, T prime, and to select all that apply. So that means there could be more than one answer. So you want to go through them all and make sure you circle all that apply. The length of each side of R prime, S prime, T prime is less than the length of a corresponding side of RST. Since it's saying it's less than, that means it shrunk down, so it would be a dilation, and we did not do a dilation in there. We just did reflections and a rotation, so all the sizes should stay the same. B states the length of each side of R prime, S prime, T prime is equal to the length of its corresponding side in triangle RST. That is true since there was no size change. C, the length of each side, R prime, S prime, T prime, is greater than the length of the corresponding RST. We said there was no size change, so that's out. D, the location of each vertex of triangle R prime, S prime, T prime cannot be the same as the location of each vertex of RST. That's not true. We just said that since we reflected across the X and we reflected across the Y and then rotated 180 degrees, it took us right back to our original position. So each of the vertices are in the same spot as what they were before. And since this one said cannot, that one's out. The location of each vertex of triangle R prime, S prime, T prime must be the same as the location of each vertex of RST. That one's true. All right, so that's number 4. Number 5 says the given angle P is congruent. Oh, I need my draw. One sec. All right, so it says angle P is, here's angle P, is congruent to angle J. So that means they have the same measure. Angle Q is the same measure as angle K. And what we're trying to prove is that KL, so side length KL, is 2.8. And it says an incomplete proof is shown at the table, and so they want us to complete it. All right, so step 1 is always the given. So they've listed what they told us was the given up here, but they've also listed the given sides based on the diagram. And the next step is making the statement that these two triangles are similar to each other. That's what that little squiggly sign means. So similar means same shape but different sizes. What gives triangles the same shape is having the same measure for each angle. So P and J are equal in measure, Q and K are equal in measure. So that means these two also have to be equal in measure because all 3 angles have to add to be 180, and so would these. So they are similar to each other.
Ridgeline, please come to the main office. Ridgeline to the main office.
So they are equal to each other based on what we call angle-angle similarity. As long as we know two of the angles are similar, then we know all three of them are similar, and then they're going to have the same shape. So the triangles will be slimmer. So that would be angle-angle similarity. You're going to drive me crazy. So angle-angle. Oh, sort of. I'm going to lose my mind. So understand that's angle-angle similarity. Then the next step is showing that segment KL, that length over QR, because those would be corresponding, is equivalent to JL over PR, because those are corresponding. So basically we've set up a proportion. And what we know about triangles that have the same shape, that have the same shape but are not similar sizes, well, similar triangles, their sides are proportional. Their angles are the same, but their sides are proportional. And that's what they've set up here as a proportion. So the statement would be then, the measures of corresponding angles of similar triangles are equal. No, my God. Sorry, I'm losing my mind today. Corresponding sides of similar triangles are proportional. One second. So based on that proof, step 2 was proven by angle-angle similarity. So that knocked out C and D. And then since they set up a proportion for the side lengths, the reason we know that to be true is because corresponding sides of similar triangles are proportional. So it's A. All right, for number 6, it says, in the figure shown, segment QP is congruent to segment QR. And so that means here we have an isosceles triangle. And what we know about isosceles triangles is that the angles opposite those congruent sides are also congruent. So those two angles are equal to each other. What they're asking for is the value of x. So we're going to try to find x. The other bit of information they supply us with is that this angle here is 70 degrees. So what we have here is two intersecting lines, and if we know this angle is 70 degrees, then the opposite angle from it is also 70 degrees. Those are called vertical angles. And what we know about the vertical angle theorem is that those angles are equal to each other. So if this is 70, then that means this one's 70. And based on this being an isosceles triangle now, since these two sides are congruent, then their opposite angles are also congruent. So if that's 70, then this one's 70. And now we know two of the three angles of this triangle, and the three angles of a triangle add up to be 180. So to find x, we can just take 180 minus 70 minus 70. Sorry, my handwriting's being terrible on this thing. So 180 minus 70 leaves me 40 degrees left for x. So x equals 40 degrees. For number 7, it says, which statement describes the additional information needed to prove that segment QR has a length of 18? So for that to be true, we see that this side length JL is 8 and this side QS is 8. We also see that this side LK is 12 and this side SR is 12. So what we're trying to prove is these two have the same length, like the JK is going to be the same as QR. So we need another bit of information. So this is where we get into our triangle congruence theorems. So we need to find out, we have two sides. So it's either going to be based on side, 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 or side, angle, side. So let's go through our choices and see what works. So as they said, if angle J is congruent to angle Q, then the two triangles are congruent by side, side, side. That's not true. We only know that two sides are congruent, and then they're just telling us an angle is congruent. So that's not telling us that all three sides are congruent. If they told us that those two angles were congruent, angle J and Q, then that would be angle side, side, and there is no angle side, side theorem. So A is out. If J and Q were congruent, again, I said that would have to be an angle side, side, and there is no angle side, side theorem, so B is out. Angle L is congruent to angle S. So if angle L is congruent to angle S, that would be side angle side, and that would work. But for part C, they said those two are congruent, and by side, 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 we know that those two triangles are congruent. It's not by side, side, side. It's by side angle side that we know they're congruent then, if those two angles are congruent. So our answer is D. For question number 8, it says, starting with segment PQ, so if I had a segment PQ, they're saying a square will be constructed using a compass and a straight edge so that PQ is one of its sides. So if I was trying to construct a square using this side, I would put my compass point on, for me, I like to work with the right-hand side, but you could do it on either side. If I put the point of the compass here on Q and I put my pencil on P, I could use that radius to draw a semicircle and then extend this line out, make sure it's extended out, and create a perpendicular bisector right here at Q by putting the point of my compass using that same radius on P and draw a line out here, put the point of the compass out here where this semicircle intersected this line, and use that same distance on that radius using my pencil here, and then where those two arcs would cross, I would connect that point to Q. So I would draw my line out here, and my drawing's not very good, but if this was a true semicircle, that point where they meet would be the next vertex of the square. And then I could do the same thing here. So let's say that's PQR, extend it out, do that same semicircle thing, and then where those two intersect would create my third point and then connect them. Again, I'm just doing this freehand, so it's not going to be perfect like that. So that's how you go about constructing a square, by creating that perpendicular bisector using that side length by extending it out. All right, so the question is, which other constructions must be completed during the construction of a square? Select all that apply. A bisector of a right angle. We're not bisecting a right angle. If I had a right angle, bisecting it would be making it into two 45-degree angles. That's not what we're doing. For B, the perpendicular bisector of PQ. If I made a perpendicular bisector of PQ, it would be going up the middle of that PQ, and that's not what we did. C, constructing a right angle with either vertex P or vertex Q. That is what I did over here. I created a right angle right here at that Q, so yes. D, a segment with the same length as PQ. We did create that same segment length as PQ because a square has to have all the same side lengths. An arc of a circle with center P or center Q, and we did that. So I did center Q, creating an arc with that center. So C, D, and E would be that. For number 9, it says, in the following figure, triangle DEF is mapped onto triangle ABC. So DEF would be our pre-image, and triangle ABC would be our image. So we're going from this triangle, so DEF to ABC, and by dilation with center N. Says if the distance from E to N is 16, and the distance from B to N is 20, what is the scale factor of the dilation? So the way we can find that scale factor, remember scale factor we usually represent with lowercase k, and it's always equal to the image over the pre-image. Sorry, this pen's acting up. So in this case, the image distance would be going to ABC, so that would be 20, over the pre-image distance, which would be 16. And then just to divide that out, and again, this is in that non-calculator section, so you would have to do it like this. Sorry. Oh my gosh, this pen is driving me crazy. So 16 goes into 20 one time. $16 goes into 40 two times. 2 times 16 gives me 32. $16 goes into 80. 5 times, and that gives us exactly 80. 0. Sorry, this is horrible. All right, so 20 over 16 divides into 1.25. So the scale factor is 1.25. Number 10, the square pyramid shown in the following figure will be sliced by a plane. So it's like if we sliced it in any kind of direction, they want to know if I sliced it and then what would that slice, if I sliced it and then broke it apart so that I could see the top of that slice or whatever, what shape would I see? So in slicing a square pyramid, so again, that's important to know that the base is a square. So if that way, if they want to know what two-dimensional shapes are possible cross sections when we slice that pyramid, okay? So if I slice it vertically, if I took a slice right down the center, then what I would end up seeing is a triangle. If I sliced it horizontally, so like right here, I would see a square because it's a square-based pyramid. If I sliced it at an angle going down, what would happen is this side would be a short length, and if I went down this way, then the bottom of that would be a bigger length. So what that gives us is a trapezoid. I cannot think of a way that if I sliced it, I would end up with a rectangle. No, and then there's no way to get E because there is no six-sided sides on this in any way, shape, or form. So our answers are A, B, and D. But that's what it means to slice something and to look at its cross-section. What would that look like if we sliced it with a knife and then opened it up and to look at that cross-section, that image? Number 11, we're given that triangle XYZ with line K containing point Y, and that K is parallel to segment XZ. So this line is parallel to this line. And which statement will most likely be used to prove that the angle X plus angle XYZ, so XYZ is this angle 2 here, plus angle Z add up to be 180 degrees. So if we were writing a proof, they want to know what statements would possibly be in that proof, or would be most likely in that proof. So with this situation, the fact that line K and XZ are parallel to each other, think of this XY line as a transversal then. And if that's the case, then angle X would be equivalent to angle 1. And then looking at it from this direction, K and XZ being parallel, and this line being a transversal, then angle Z would be the same as angle 3. Oh, I hate when it's doing this. I don't even know why it does that. All right, so I was saying angle Z is going to be the same as angle 3 because those would be alternate interior angles for the same reasoning why these X and angle 1 would be alternate interior angles and therefore equal. And then if you notice, angles 1, 2, and 3 then add up to be 180 because they make a line. So those would be statements that I would use in this proof. So let's look at our choices. We have for part A, or for answer A, the measure of angle 1 being equal to the measure of angle X. That is something I did use in my proof that I was just stammering on through. So A would be an answer for me, but I do want to double check and make sure, because it does say which one would be most likely, so I just want to make sure none of the others would be one of the statements I would use. Angle 1 equaling angle 3, those are not necessarily true, so that's not it. angle 2 being 90 degrees. It may look like it based on the drawing, but you can never assume. So that did not apply. And they did not tell us that. And then angle 2 plus angle Z equaling 180. If angle 2 and angle Z add up to 180, then this would not be a triangle. That's just two angles, and that would not be a case. It could not make a triangle then, because X would have to be 0. So that's out as well. So angle A is our answer. All right, so number 12, it says use the given information to answer the question. Triangle ABC is shown in this XY plane, and it gives you the coordinates of point A, point B, and point C. They're asking, what is the area in square units of triangle ABC? So what we can do is the area of a triangle's formula is 1/2, sorry, my pen's acting up, times the base times the height. So if I think of this AC line right here, that is such a nice, easy one to find the distance of because it's along the same grid line. They both have a y coordinate of 3. So I just need to take this 16 for its x coordinate minus 2 for point A's x coordinate, and that gives me the distance of 14 for the base. Okay. For the height, I could just go along this grid line here from B to where that grid line worked for A. And that is a distance of, and you just can count the blocks or you can use the y coordinates. So 11 minus 3, so that has a distance of 8. And we just do area equals 1/2 times 14. Sorry, this pen looks terrible. Times 8 for the height. So 1/2 of 14 is 7. 7 times 8 gives me 56. And this would just be 56. They didn't tell us what the units are, so we would just say units squared. And of course, none of that came out right, so just ignore that. But the answer is 56 units squared. All right, so for number 13, and this will be the last one I do for this video because this is the end of section 1, says given lines K and N intersect to form angles 1, 2, 3, and 4. Prove that angle 2 is congruent to angle 4. Our incomplete proof is shown here. The spot we're missing is right here. So we need to know, how did they go from the previous step to that step? Like, how do I justify that this is what we got? So going from this step to this step, we see we have the measure of angle 1 plus the measure of angle 2 equals the measure of angle 1 plus the measure of angle 4. So, and to go from that to equaling measure of angle 2 equals measure of angle 4, it looks like they just subtracted the measure of angle 1 from both sides of this. So just using algebra skills. And what we say that reasoning then is called subtraction property of equality, because all they did was subtract. I'm gonna pause the video and then scroll down and show you your options real quick because it won't let me do it while I'm drawing. So under here, I don't know if you guys see this box or not, but it says which reason for step 6 correctly completes the proof. We have A is substitution, B is the reflexive property, C is the subtraction property of equality, and D is the definition of supplementary angles. And like I said, we just subtracted going from step 5 to step 6. So the reason we know step 6 is true is the subtraction property of equality. All right. All right. Thank you for bearing with me with my difficulties with my pen, with using PowerPoint screenshot, or screen recorder. I apologize for how messy it is. I like things to be a lot cleaner than this, but it is what it is. All right, so I will pretty soon make the videos for sections 2, 3, and 4 to make that available for you. But right now, here is section 1, the non-calculator portion of this practice MCAP test for geometry. Have a great day.